All right, welcome. This is Physics Chapter 1, Lecture 2. You'll want your book open to page 21, and your notes, we're going to start on page 3, where it says velocity is relative to the observer. And I have a space here. It says demonstrate in gym. Can't really do that on this video, so I'll just have to draw a couple of things out. But you need to memorize this equation, the relative velocity equation. So relative velocity is the velocity of what is being observed minus the velocity of the observer. Okay, so what do we mean by relative velocity? Okay, let's say you're driving in a car. And you're just going down the highway in this direction at 50 miles an hour. And let's say we have car 1 and we have car 2. And car 2 is driving down the same highway. Let's say it's a 4-lane highway, so right beside you, also at 50 miles an hour. If you were to look, if you're in your car and you look out the window at the other car and they're moving the exact same speed as you, and you don't look at the surrounding trees going by and all that, you just look at them, it looks like they are going 0 miles an hour because they're not moving relative to you. All right, so let's say that car 1 is moving at 50 miles an hour this direction, and then car 2 is moving at 50 miles an hour this direction. If that's the case, the relative velocity is actually 100 miles an hour, because in car 1, let's say you're in car 1, you're moving at 50 miles an hour, and car 2 is coming towards you at 50 miles an hour. It looks, as far as your observation goes, it looks like that car is coming at you at 100 miles an hour because it's your velocity plus the other car's velocity. Okay. So let's go through the math of this. Let's look at on your own 1.7. Okay, so we are on page 23. So we'll go through this. It says a boat is traveling up a river against the current. A boy on a raft is floating down the river with the current. They're both being observed by a fisherman sitting on the shore. The fisherman observes the boat traveling 15 meters a second up the river and the raft 3 meters a second down the river. What's the velocity of the raft as observed by someone on the boat? And what's the velocity of the boat as observed by the boy on the raft? Now, as we go through this, if you're confused at all about this, make sure to read example 1.5 in blue on page 22. That will definitely help you. All right, so let's go through 1.7 on page 23. I'm going to draw this out. So we've got a river here. We've got a boat, and the boat is going down the river at 15 meters per second, or excuse me, up the river. And then we have a raft, and the raft is going down the river at 3 meters per second. All right, and then we have a fisherman that's observing from the shore these two speeds or velocities. Okay, so we've got a raft and a boat. Okay, our first question, we're going to use this equation. Relative velocity is velocity of what's being observed minus the velocity of the observer. What is the velocity of the raft as observed by someone on the boat? Okay. It's the velocity of the raft is going to be the velocity of what is being observed. So let's call this, instead of velocity relative. What is being observed is the velocity of the raft minus the velocity of the boat. Now we have to define our direction. Let's say upstream is positive direction, and then downstream is the negative direction. So that's going to be velocity relative is going to be, the raft is going downstream, which is negative, so that'd be -3 minus the velocity of the boat, so minus 15 meters a second. It's minus the positive 15 meters a second. So that's going to be -18 meters per second. So it looks like for someone on the boat that the raft's coming at them at 18 meters a second in the negative direction. Okay, so that's part A. Part B is what's the velocity of the boat as observed by the boy on the raft. That's going to be the velocity of the boat minus the velocity of the observer, the raft. All right, so that would be 15 meters a second minus -3 meters a second. Okay, minus, the raft is going -3 meters a second because that's how we defined it. So minus negative would be plus, so that's 18 meters a second. So the boy on the raft thinks, the way it looks, that the boat's coming towards him at 18 meters a second. So I hope that makes sense to you. Make sure to read that example 1.5 if this is a little confusing. All right, but you definitely need to understand relative velocity for the test coming up. Okay, pause the video if you need to, and if you need to finish up your notes, and I'm going to do some erasing. All right, the last concept in this chapter is acceleration. Okay, so acceleration is the time rate of change of velocity. Rate of change of velocity. Okay, the acceleration equation. So we got to memorize this. You'll need to memorize the relative velocity equation for acceleration, which is a vector quantity, is the change in velocity over the change in time. So that's like the final velocity minus the initial velocity. If you start with the speed, of course those are vectors, over the change in time. All right, and another, instead of writing out velocity initial, the way that the book shows this is V naught. And the way that the book shows the final velocity is just V. Okay, so final velocity is just V, initial velocity is V naught, a little zero there. Okay, back to the notes. Acceleration can mean either speed up or slow down, be either one. So you can have a negative acceleration. And this one's really important. If acceleration and velocity have the same sign, it's speeding up. If the signs are opposite, the object is slowing down. So you'll have to be able to read a graph and determine that. All right, let's go through some on your own problems using the acceleration equation. We'll start with 1.8. So this is on page 27. So 1.8 says a sprinter starts from rest and in 3.4 seconds is traveling with a velocity of 16 meters per second east. What is the sprinter's acceleration? Okay, so starts from rest, so that means, so our final velocity is 16 meters a second. The initial velocity, V naught, is just 0, because that's rest. So acceleration is going to be 16 minus 0 over the time, and it took 3.4 seconds. All right, so that's 16 divided by 3.4, so that'd be 4.7 meters per second. But this last part is important. It's a vector, so we have to give the directional information of east. All right, 1.9. Let's see if we can fit this in here. Also on page 27. Says a race car accelerates at negative 7.2 meters a second squared. Okay, so the units for acceleration are some distance per time squared. Okay, let's make sure we know that. So meters per second squared in this case. If it takes, and so I did that wrong on the previous one. Meters per second squared would be the unit. Sorry about that. So if it takes, the brakes are applied, if it takes 3.1 seconds to stop the car when the brakes are applied, how fast was the car originally moving? So we know that acceleration is equal to the final velocity minus the initial velocity over the change in time, and we are trying to figure out how fast was the car originally moving. So that would be this V naught. That's what we want to know. Okay, so let's just fill in the numbers. We got negative 7.2 meters a second squared is equal to, now what's the final velocity? Okay, it's a stop, so that'd be 0 minus V naught, what we're trying to figure out, and the time is 3.1 seconds. All right, so we're going to multiply both sides by 3.1 seconds, so we'd have negative 7.2 times 3.1 is equal to negative V naught. Right, so that is going to be negative 22.32 meters per second is equal to negative V naught. So you can divide both sides by negative 1, and the original velocity is 22.32 meters per second. All right, cool. Okay, let's go ahead and finish this chapter up in terms of math. So go ahead and pause the video if you need to. And we're going to look at velocity versus time graphs. Okay, so we are on page 28. Velocity versus time graph. So with a velocity versus time, not position versus time, we did that last lecture. Velocity versus time graph, the slope is equal to the acceleration. The area under the curve is the displacement. Okay, so let's look at, on your own, 1.11. Right, on page 29, it says, during what time intervals is the object's speed increasing? So when is the acceleration increasing. Well, the acceleration is increasing when velocity and acceleration have the same sign. So I'm going to go ahead and write this out. So speed is increasing when velocity and acceleration have the same sign. Okay, so that is, go ahead and write that sentence in your notes. I wrote them on my notes here. So when velocity and acceleration have the same sign. So let's take a look at this. So on this graph, you can see velocity is positive above this 0 point on the y-axis and negative below the 0. Okay? So from 0 to about 6 seconds, velocity is positive because we're in the positive part, but acceleration is negative because the slope is negative. Okay? So it's not speeding up there. From 6 to about almost 12 seconds, let's say 11.8. 6 to 11.8. The slope is positive, so acceleration is positive, and the velocity is in the positive part of the graph. So from 6 to 11.8 seconds, both velocity and acceleration are positive. They're the same sign. Okay? So if they're the same sign, they could both be negative and it'd be speeding up, but it's speeding up here. Here, acceleration is negative because the slope is down, but velocity is positive, so it's slowing down from 0 to 6. All right, how about from about 11.8 to 16 seconds? So 11.8 to 16 seconds, acceleration's negative, but velocity is positive, so it's slowing down there. But then from 16 to 20 seconds, so we know that's part of the answer, both velocity and acceleration are negative. They have the same sign. How do I know they're negative? Well, the velocity is in the negative part of the graph, right, below this 0, so it's down here. And the slope is negative, and that tells you acceleration. So from 16 to 20 seconds, also speeding up. So both of those are speeding up. Slowing down where they have opposite signs. All right, 1.12 says, when is the object's acceleration 0? Well, it's 0 when you have a slope of 0. And you have two places where the slope is 0. At 6 seconds, right, because it's changing direction there, and at about 11.8 seconds. So where slope is equal to 0. So that'd be 6 seconds and almost 12 seconds, about 11.8 seconds. Now, if we wanted to figure out the exact acceleration somewhere on this graph, we would need to figure out the slope, okay? And we could do that, and you'll have to do that in the homework, all right? Just like with the position versus time graph, we just want to pick, you know, so somewhere in here we could find what the slope, what the acceleration is at 8 seconds. We would just pick a couple of nice places on the graph to read, like between 8 and 10, and figure out the slope there. No problem. All right, the last thing before I assign the homework, and I do have one more lecture for this for chapter 1, If velocity is 0, acceleration is not necessarily 0. And if acceleration is 0, velocity is not necessarily 0. So if you have a constant velocity, so if you're going along at, let's say, 10 miles an hour, my table's making a lot of noise, sorry about that. All right? If you have a constant velocity, so you have a velocity, but acceleration is equal to 0. Now let's say it says, the first one says if velocity is 0, acceleration is not necessarily 0. Let's say you threw something up in the air. All right? You threw something up in the air and it turned around and came back down. So this is the ground. At this point right here at the top, velocity is 0 momentarily at that point. But the acceleration is still occurring because it's accelerating due to gravity. So we'll talk about gravity next chapter. All right, but acceleration does not equal 0 there. It actually is equal to 9.8 meters per second squared. It's actually negative because it's going down, because that's the acceleration due to gravity. All right, so just be careful with that. Your homework is to finish up the review questions and practice problems. So that's going to be review questions page 34, 5 through 10. All right, that's the review questions. And then practice problems page 35. All right, last time we did through number 6, so it would be 7 through 10. And I will make a video that you can watch to make sure you got the homework correct or make corrections after the homework is turned in. Okay, that finishes lecture number 2. I've got a very short lecture number 3 for chapter 1 coming up in just a little bit, and I will see you next video.